path finding algorithms. Let's check Wikipedia. It is a more practical variant on solving mazes. Field research is based heavily on Dijkstra's algorithm for finding the shortest path on a weighted graph. It's closely related to the shortest path problem within graph theory, which examines how to identify the path that best meets some criteria. Searches a graph by starting at one vertex and exploring adjacent nodes until the destination node is reached. Generally, with the intent of finding the cheapest route. Although graph searching methods such as breadth first search would find a route if given enough time, other methods which explore the graph would tend to reach the destination sooner. Rather than examining every possible route in advance, the person would generally walk in the direction of the destination and only deviate from the path to avoid an obstruction, and make deviations as minor as possible. Open set of candidate nodes. At each step, the node in the open set with the lowest distance from the start is examined. Interesting. The algorithm begins with a start node and an open set of candidate nodes. At each step, the node in the open set with the lowest distance from the start is examined. Okay, maybe that's what we need. Could actually solve both our problems, like targeting the closest enemy and also finding the fastest way to the closest enemy in one. Algorithm. Yeah, we just need the adjacent nodes actually added to the open set, because let's create a new. This is actually really cool. Yeah, I think I see how this would work. So we have this thing here. Oh, should have done it with 5. So we have this thing here. Hey Dota, doing good. How are you doing? Right now I'm trying to figure out pathing in this little game or world so that our characters or the pawns on the board can figure out where the closest enemy is and then target that and walk towards it. Was looking through testing resources. Okay. Did you find anything good? Haven't done Jigstraws in a long time. Yeah, it's new to me, to be honest. So it's interesting. I think I'm starting to understand how it's gonna work. Just look through. Can't tell, I was kind of disappointed. Okay. So we're just gonna like take, okay, here, we're starting node, take that as input. Take all the adjacent nodes. So let's call this like 1, 1, 1, 1. Just gonna look through here for enemies. If it finds one, we're good. If not, keep looking. So add all the adjacent nodes to this one. 2, 2. This is already done, 2. Same for this one, all the adjacent node, 2, 2, 2, 2, 2. 2, 2, 2. And then we'll just continue like this. Get everything around it. Say it finds an enemy here. How will it know though what the way to this was? Well, this is going to be added as part of this node. So it will then be able to backtrack how it found that one, I think. Looks like Minesweeper, yeah. ChatGPT was a lot better at finding good SQL performance books than testing. Oh. So what do you want to do with testing? And I'm guessing this is gonna work even though there is a, like, let's say there is some kind of blockade here, some kind of hurdle here. Then this algorithm, this is now gonna become a 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's say that we want to go here. This is the target. Let's make it into a different color target. Testing is just a topic I'm constantly exploring. Oh, cool. Yeah, I think testing is it's a pretty interesting topic actually. Like when I first got into computer science or like programming and stuff, I thought it sounded very boring, but I'm starting to like it more and more. It's like so important, and it's part of the development, like with test-driven development and stuff. I really like smart testing. Is it's so rewarding, I think. I asked it SQL, authentication, and testing, my framework.net. Those were all the topics. Okay, nice. So what are you building? Are you building anything specific? So here, let's erase these. Oops. Now. Oops. So now with the algorithm, we're gonna have 1, 1, 1, 1, 1, 1. Then there's gonna be 2, 2, 2. And same here. 2, 2, 2. And then there's gonna be 3 and 3, and we're finding it. This is what we want to go for. And then we need to be able to backtrack to figure out this is the fastest path right now. 1, 2, 3 steps. This is exactly what we need. Currently building an expense reporting system. Kinda boring to build. Likely backburner that project soon. Interesting. So is it like for your own your own expenses, or what's your what are you gonna use it for? Or is it just for like learning and figuring out stuff? So how do we implement this algorithm? And I deliberately want to try to figure this out without looking it up first. Not a lot of comprehension problems, and it's easy to be a domain expert in that. Okay. What do you mean it was originally a kata? What does that mean? So we don't want look at range. We want the pawn to do find closest enemy. Kata are like mini programming problems. The goal is to write tests around them and refactor the code safely. Okay, cool. So can you find this online, or like where do you find that? TDD kata coding. Exercises. Okay, that's cool. Is this like the kata? That's from. I remember that now. It's from like some martial arts, right? Originally, it's like this sequence of things that you do. A medium article, yuck. Yeah, well. Refactor, okay. Bowling, Christmas lights. Nice. Emily Beige. Who is that? Technical coach, YouTuber. Nice. Got it, got it. Find closest pawn. Do we want some kind of path to it? We want both, I think. We're gonna be finding I think every one of these squares need to remember their parents. We have like Dijkstra's D square, and it has a parent. And then it will spawn new ones, closed, open. I think I need to break this problem down a bit. I think it's becoming a bit too much to keep all in my head at the same time. Okay, let's do path. We should call it a path. Need an object for path. Find path to on. No, I want to do them both at the same time. I don't know the pawn beforehand. And we want to do this both for finding enemies and friends. Enemies and friends. I'll read some more about it. Dijkstra's algorithm, finding the shortest paths between nodes in a weighted graph. Oh, you can make it weighted, so like different terrains. If the speed is slower on a certain terrain, you can give it a different weight, I believe. Road networks, for example, was conceived by computer scientist Edgar Dijkstra. The algorithm exists in many variants. The original algorithm found the shortest path between two given nodes, but a more common variant fixes a single node as the source node and finds shortest paths from the source to all other nodes in the graph, producing a shortest path tree. For a given source node in the graph, the algorithm finds of one of two shortest path trees where the root vertex is the red square. The edges in the tree are indicated with green lines, while the two dashed lines are edges in the full graph, but not in the tree. The numbers beside the vertices indicate the distance from the root vertex. Okay. So maybe we should build trees then. Like everything here. Yeah, this becomes like a tree. This doesn't have, this is gonna be occupied, so it doesn't have to take that one. But it's gonna become like that. And then like that. And then like that. And then like that. And like that. Yeah, so we have trees. And that's how, when we come here, we can go back in the same tree and there's only one path. Trees. Build trees. Let's just call it find path to closest enemy. Done. And the path is a tree. And it doesn't take any parameters, that method. So a path, if we have a tree that does something like this, there is a path here. This is what we need. But it's part of the tree. We extract it from the tree when we find the target. Yeah. So we want the path. Find path to closest enemy. So what do? We What does the tree object look like? So we have trees, and then we have tree. The tree contains paths. Is that a reasonable hierarchy? And then we iterate over the trees and expand the paths in those trees for every iteration until we find what we need, and then we have our path. So we need to like scan. Scan connecting squares. I think doing this in Java is slowing me down now. If I did this in Python, I think it would be faster. I could just run, like, test it out much more frequently, I think. Just want to remove this and see if at least it can run now. Yeah. Okay. So it's going to be something like while let's say enemy found, boolean enemy found equals false, while not enemy found and board boolean board space and board left to scan is board. Let's do that. Is board left to scan. Always true. here we need to initiate then a new round. So for every top node for every path, we need to take the top node in every path. Path paths equals like that. Then if there is board left to scan and we haven't found the enemy, which we haven't when we start, initiate sequence where we do for every path for path, we take the latest for path in path in paths. Take path, the one at the end, length, paths dot, no, not paths dot length, we need path dot length. Get length, we need to create that method. Oh, just let's say get end node. End node. Last node. Which is in the beginning is going to be the current position. And with that last node, we want to do scan for available and unoccupied. Scan around. Scan for enemy or new path. And every time we find a new, I think, yeah, this is interesting. I really need to think hard about this. Like how the board right now is so vague. And now I'm trying to implement an algorithm here without being able to like continuously test it at the moment. I will figure this out though. It's gonna be super cool when we can put like this warrior here and this goblin here and some, I don't know, not a maze, but like a wall here, and they can figure out like the closest way to each other and start moving towards each other and then start hitting at each other. And then we can like find a healer or like some ranged units, and they can also walk around here until they are in range, and then they can start shooting. Yeah. But the key to all of that is gonna be unlocking this Dijkstra's algorithm. And I'm sure I can find the code somewhere for like a smart implementation. But I would like to figure that out. And then refactor and improve it. What if we build the path class? Maybe that will help. Making this a bit more concrete. So a path will contain an array of squares. And every endpoint in the path, we want to create X amount of new paths based on the previous path if we didn't find anything at that point. Hmm. Programmera.
Sitter du och tänker? Eller pratar du med någon?
Streamar. Men nu sitter jag och tänker.
Fattar.
So, kind of want to be able to use a path to create a new path. If we give it a we want to be able to create it with a path only. No, not path only. That will never be the case, I think. But a new square. or just a square when we're starting off. Path, 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 no, square, square. And in this case, we want to do this dot squares equals square. Array access will produce null pointer exception. Okay, so we don't know how long the array is. We might need to introduce a list. We don't know how long the path is gonna be. Right. I'm actually gonna take a little break now. We've been going for around 2 hours this session. I still hadn't had my first meal of the day, and it's about 1 p.m. here. So I will take a little break and then probably come back later to try to solve this Dijkstra's algorithm puzzle in a as clean way as possible. Right, thank you so much everyone who tuned in, both on Twitch and to everyone watching this on YouTube in the future. Please drop a follow, subscribe, leave a comment if you have any feedback, and see you next time.